A very warm good morning, participants. Now we will move to our next session, Renewable Energy Resources, Geothermal Energy and Climate Change. I like to invite our chairpersons, Dr. A. Krishnakumar and Dr. Y. A. Murkote. There will be three presentations, first by Dr. Ranjit Khangar, then Parvez Alam sir and Mamta. So now I hand over the dais to our chairpersons.
Dr. Krishna Kumar to give the open comments for this technical session, which is interested for renewable energy resources, geothermal energy and climatic change. So I now hand over to Dr. Krishna Kumar, sir.
Okay, very good morning to you all. So actually, this is a technical session 7, renewable energy resources, geothermal energy and climate change. Actually, so the previous session is one of I think very important that we are discussing today. So hopefully, I think so 10 minutes that is given for each presenters. Actually, as per the list, there are 5 presenters. Actually, I think now only 3. I think. So, Joe, please restrict your presentations in time. I think like 10 minutes that is allocated. And actually, so I invite Sri Ranjit G. Kankar and Mugut Kumar Singh for the presentation entitled Coal Fly Ash of Thermal Power Stations of Central India, Rare Elements Potentially for Renewable Energy Perspective. Please.
Good morning, everybody. I am Dr. Ranjit Khangar, and today I want to present our findings of one of our research project, under which we have done extensive study of the all coal mines of Central India, and we have collected coal sample from different coal seams of every mine, not every but almost all mines of the Central India, and we have documented all the data, and from that time we have also, to make it complete study, we have also collected sample from mine drainage as well as coal ash to understand the variability of the these RE and critical elements in the coal. And out of that whole study, I am presenting today what is our findings from the samples we have collected from the different thermal power plant of the Central India. And so this is the topic. Background of this study was, as we know, RE is the presently most important commodity, and as we want to achieve our target of Make in India as well as Digital India, as per our PM's and our country's ambitious program, so we required a lot of RE for completion of that program. But unfortunately, as we know, that most of the RE, that is 84% of the RE, is controlled by the China. And then indigenous resources in India are very low, and which is creating, which is we required for our growth as well as the national security. And that's why it is strategically also very important to have our own RE resources. And it is found that in some coals of China, USA and Russia, that it is having higher concentration of RE. India produced 778 million ton of coal, and we consumed out of which 697 million ton in power generation. And as we know that Indian coal is very high in ash, we are generating almost 174 to 330 million ton of ash, considering the 25 to 45% of the ash ratio. Indian coals are yet not fully studied for the RE concentration, and therefore Niti Aayog suggested government, GSI as well as the other organization to study these Indian coals in detail for their RE concentration. Therefore, we have taken this study, and this is the prospective view of the next up to Vision 2030 when we want to achieve our goal of the Make in India as well as Digital India. And this is the data from the on Energy, Environment and Water of June 2016 report. And as we find that these are the most critical area, and where RE is also going to be very critical. And these are the least critical area. This is the moderately critical and moderately critical. And we find that most of the element, particularly RE, are going to be very important commodity and critical commodity from point of our country. And this is the study already done at the China and US, and they found that there are different elements can be recovered from the coal. Most of the critical element as well as the RE can be recovered. And as we can see that in this table, this green color, that is highly promising for the utilization. The highly promising element or RE are those which can be presently recovered at the laboratory scale or pilot scale, but not commercially recovered at present stage, at present technological conditions. And this is the coal consumption scenario in India, as most of the people are suggesting, and my earlier speaker was also told that though we are planning to go in big way with the renewable energy as well as the other source of energies, but still it is the real picture and real fact is that we have to be continually depend on the coal. And this is the this is one of the report which I am quoting here, that in 2040 also more or less 48% of our energy resource is coming from the coal only. So we have to deal with the coal, and we have to be dependent on the coal for our energy resources, because we are a very big country and we need to be secure our energy demands for our huge population. That is our priority, as well as we are having the ambitious programs to develop as a developed nation. So energy security is very important. May it comes from the renewable energy or non-renewable energy, but first it is required, energy is required for everybody. So when our 48% of energy is coming from coal, then this suggests that huge amount of ash will be generated for the long duration time. So there are two problems with the ash. First, we have to use that ash for some purpose, and it is without using that ash, it is creating hazards for the environment and ecology. So if we able to create some value addition from that ash or recover RE and critical element from that coal ash, it will be very win-win situation for everybody and country, because the ash is huge amount. So we can generate a lot of resources if we can develop the good technology on this. And this is the world view of the RE content in the different coals, and this is the suggested cut-off grade, that is 1000 mm. Average coal ash is containing around 400 to 500 ppm RE, and in many coals, in particularly USSR and China, it is having higher concentration of RE, but in Indian coal as well as in USA, we are not getting that much higher concentration of RE. And this is the UCC normalized RE distribution pattern in our ash sample of different power plant, and we see the depletion in C and EU values here. And these are the different RE mineral we have studied under ACM from that ash sample, xenotime, monazite and zircon. It is found in the ACM and EDX studies. And this is the X-ray diffraction pattern, and you can see the quartz and mullite are present in the this ash sample. And this is the detailed table of the different detailed table of the RE concentration in the different sample of all the power plant, as fly ash as well as bottom ash. And you can see from the table that the RE concentration varies from around 400 ppm to as much as 607 ppm. And in RE case, we have to not only see for the RE, but we have to evaluate the RE from the characterization of the RE. That is, what much amount of LRE is present there and what much amount of the HRE is present there. Because HRE is more important than LRE and LRE is more abundant than HRE. So if our sample is having better HRE concentration, then it will be very, very useful, and at the lower percentage also it can be economically viable. So this is the correlation ratio of the LRE and HRE. As our most of the Gondwana coal is developed on the granitic terrain and the sediment is coming from the granitic area, our most of the sample is containing more LRE than HRE. And this is the different parameter for study, and we have calculated the critical ratio, critical value as well as the uncritical and outlook coefficient and critical percentage. Critical percentage is the percentage of the critical versus uncritical or excessive REs. And from this data we have plotted this, and here I want to show these things. These are the different classification as per the present availability, market price and utility of the RE, and these are categorized as excessive. These are the REs which are available in large quantities and these are not that much critical. But this ND, EU, TB, DYY and ER are very, very important, and these REs we are looking for our, from electromagnet to solar panel to everything. These REs are most important REs in this case. And how this critical percentage is derived? This is the critical RE versus total RE into 100. This is the critical percentage, and this is the coefficient outlook coefficient of the RE. That is your critical RE concentration versus the excessive RE. Ratio of the total RE with the critical RE and divided by the ratio of the excessive RE with the total RE. This is your outlook coefficient. And as per the sardine, as per the DIE 2017, if our outlook coefficient is more than 7 and critical element is more than 30, then that resource is promising source. So from this data we can see that most of our sample, barring these 4, are falling in the promising source. But however, cutoff grade of RE is more than 1000 ppm for the ash, but this outlook coefficient is quite positive and LRE and HRE ratio is quite positive. So with the development of technology and physical beneficiation, we can achieve to certain level, considering the huge resource of the RE, huge resource of the ash and the RE potentiality. So in mass scale production, if we do, then it can be that cutoff grade can be lowered to certain extent, considering this outlook coefficient and critical element scenario. And these are the major advantages of this process. And this is the in US, these people of Department of Energy, National Energy Technology Laboratory, they have developed their US coal is also having very low RE, around 300 to 4 ppm. But they have developed pilot scale project, and they are trying to recover that RE from that. They are also working on the mine drainage, and we have also collected a sample of the mine drainage from our different coal mines. But what happened in our cases, in US, they are pounding that material for the so long. So they are, due to regular impoundment of the material, their concentration of the mine drainage as well as sludge has reached to certain extent. Whereas in our case, that most of the drainage is going to the freshwater zone, so that drainage water is not having that much concentration. So this is very steady supply we will get, and we will not to be depend on the conventional sources, as well as it will the reduce environmental impact. It will be very low cost infrastructure processing, as it is a fine material already, and though it is in present scenario with pilot scale, it may be somewhat expensive, but when we develop in large scale process, and considering the financial and environmental impact of this disposal, to reduce the negative impact of this disposal, we can definitely in future we can see the promising result of this technology. Thank you. Actually, there are number of methods. First, it will start with the beneficiation of this ash. From this ash, by gravity separation and other method, heavy minerals, particularly this monazite and zircon-bearing material, will be recovered by physical process. That is gravity separation and other methods. After that, there will be acid leaching, and then roasting and alkali leaching, and then organic leachate treatment. So that is very huge scientific process, and most of this is going on in US, and all these technologies are presently patented. In case of India, only as per my knowledge, Jamshedpur metallurgy, what you call that lab, is doing some RE research. But most of the case, what happened with us, that our basic study, that whether our coal is having RE and which zone or which part of that coal is having RE, that data is not available. As well as our no large scale study has been done yet on the all India basis, that all 185 thermal power plant we have, that how much RE that ash is contained. So first of all, it is required to generate our database. Then second, that with some participation with the chemical engineers and that metallurgy people, we try to derive that RE and critical element from that. So this is very scientific and technological process which grows gradually. But first we have to start at some level so that we can reach to some extent. Considering our huge resource, we have got the very huge potentiality. But to tap that potentiality, first we have to study, we have to work on that, and deep research is required in this field. So our project was just basic information, collecting basic information from the each mine, and most of the mines of the central India. We have collected around 300 samples. We have also collected drainage. We have collected, and we are correlating these things. And we found that in coal, world average is 80 to 100 ppm, but in our coal, in most many cases, it is around 700 ppm. It is going up to 700 ppm. And very interesting fact is that the RE in coal will increase by 6 times when it is burned. So there are some promising areas, particularly in Singrauli and your Tawa Valley coalfield, where RE concentration is really good. That is not above the cut-off grade, but with technology, that cut-off grade, as we know, that cut-off grade can change with the technology. Okay. If we develop the simple beneficiation process and we can reach to some certain concentration, then it can be used as a resource.
Thank you, Dr. Ranjit. Any question from audience? One hand is there.
It was a good presentation, Dr. Khangar. My query is that you said the Indian coals are rich in LRE because of their provenance, granitic provenance. So now, the requirement of HRE is more. So, what could be the provenance which can generate the HRE? That is my question, and which we are lacking in Indian coals.
Okay. Sir, that relate to the genesis of the coal and the provenance of the coal. In our case, most of the sediments are coming from the surrounding granitic terrains. So naturally, they will be higher in LRE because granitic rock is having higher LRE. So that we can't change. But as per our study, what I have shown to you, that most of these coal outlook coefficient, that is ratio of the critical as well as excessive RE is suitable. That is more than 70. And critical percentage is also more than 30 in most of the samples. So it can be concluded that these are falling in the promising source. So though we are having higher LRE than HRE, that is natural because the genesis of that and depositional environment of that area, but still it is falling in the promising source. Only requirement is that we have to study most of the sample, and we have to demarcate the particular coal zone which is more rich, and then we have to develop the technologies to recover that RE at the low cost and environmental friendly methods.
So thank you, Khangar sir. Thank you. Now I invite Dr. Parvez Alam for conservation of resources in drilling operation. It was his title. So I request him to present the data.
Good morning, distinguished member of panel, all the concerned professional present here. I welcome to all of you. Basically, I am mining engineer. I represent the conservation of dealing energy in Mineral Exploration Consultancy Limited. First of all, my present outline of introduction, fuel consumption and drilling rigs, pumps, generators of vehicles, factors influencing of fuel consumption, conservation of water, conservation of forest and environment, conservation of electricity, norms of fuel consumption for drilling, conservation of energy for solar power, energy saving through lighting, use of energy saving electric appliance, energy auditing and cost analysis and conclusion. First of all, Mineral Exploration Corporation Limited has been carried out detailed exploration of mineral deposit all over the country of more than 5 decades. So, to demand of mineral wealth of country, so as we define the different purpose of manufacturer and different exploration wells. For the said purpose, infrastructure and expertise have been remain committed to execute the cost-effective, time-bound and comprehensive program to achieve the desired goal. According to the exploration of mineral, different types of drill machine, drill rig, mud pump and compressor, diesel generator set, vehicles and put it into operation. Company has to fix the standard norms for different type of machine, a maximum minimum consumption of fuel to reduce the consumption of fuel. All drill sites are blocked basically usually in remote area and township. So we are not use any electricity crisis to operate the maximum use of high speed diesel HSD. How to control the HSD consumption of the machine, generator and pumps. All possible care is been taken operating the machine and a strict observance as well as maintenance of consumption of machine. Fuel consumption is reduced to the different way. All maintenance of machine and health of a machine and routine maintenance, preventive maintenance are should be taken along with same. Effective normal functioning of machine, drilling operation include drilling mud pumps, diesel consumption and generator operator prevailing condition factor of direct impact of normal fuel consumption. Next slide is exploration drilling activities carried out more unpredictable condition in nature. Possibility unavoidable unforeseen agency can be ruled out. Most of the exploration work in the remote area to facing a lot of problems, just like a local issue, nature also facing a lot of problems and existing industry prescribed norms of fuel consumption, yet to benefit of emission as well as national terms and conservation nature of resource and maximum extent. Factor influencing the fuel consumption. Next step. Most of the health of an engine 85% rated capacity of major and minor parts of the machine, compressor generators, overhauling the prime mover carried out religiously need to basis of schedule program. And company has to maintain a schedule operation, engineering maintenance schedule top priority basis. Major overhauling prime mover due to care being or replacement of vital component parts of the engine and machines. The effective maintenance, preventive maintenance, and predictive maintenance through drill rig, mud pumps, compressor and generators play a vital role of HSD consumption pattern of prime mover engine, fuel consumption, nozzle calibration, turn virtue of tip setting, time gear setting. The engine is done for effective proper functioning of fuel consumption as well as control carbon footprint or carbon emission parameters. So it's most important factor of quality of fuel. Most of the work is doing in a remote area, या forest area and a nearby township is quality of fuel also affected the machine performance. Most of the fuel are low quality of fuel to affect the engine capacity and result of productivity. Every low calorific value may be cause adverse effect on effective functioning of engine as well as the fuel consumption. Conservation of environment and forest water during drilling operation. Conservation of water to prepare deep sump pit to recycling of drilling water. Most of done by cementing and plastic tarpaulin, mud slurry drilling fluid to avoid wastage of water and recycling of return water. Some of the factor is most important to recirculate and consumption of water, proper surface drainage system, desilting of return water, cleaning of sump pump, proper mixing of mud pump, proper maintenance and cleaning of mud pump to stop leakage of hose pipe and different types of leakage of fuel in machine. In case of hole in forest area, most of the exploration work in forest area, so some of the precaution has to be taken to cut the trees and bushes. In case of drilling hole in forest area, to permission local forest department for exploration, after getting permission before starting drilling use and occupy minimum required space to complete the work. I am doing work two types of machine, conventional and hydrostatic machine. Hydrostatic machine is 4 times, 5 times is performance in comparison to conventional machine. So a present scenario is different. Conventional machine is used maximum is shallow depth and conventional or hydrostatic machine is used basically in deep-seated exploration work. And another case, drilling hole fall in the agriculture, crop and paddy cultivated land, provision for crop compensation as per the company rule, minimum shifted or proposed the whole as per the avoid landowner.
2 minutes.
Different types of non-fixed of generator, compressor and drill machine to control and cost control and environment control to least bothered of our HSD consumption. To define is mud pump, standard mud pump, different types of mud pump used in exploration work. Next is different types of drill rigs, old drill rigs or new drill rigs, maximum KDR 1000 or different DE 720 scientific machine is advanced drilling machine, depth up to 1500 meters. Our old machine is replaced by new machine due to the fuel consumption is more and HSD consumption is more. To reduce the time and cost of benefit, to advance HSD is used in hydrostatic machine is benefit for exploration purpose. Consumption pattern of generator set, different types of generator, low rate and high rate. Conservation of energy through natural resource. Most of the setup in Nagpur, 3 types of CHQ, CSD and headquarter of Nagpur to conservation of energy by solar system. IT division is 10 kilowatt, canteen and civil department of 7 kilowatt, utility complex 0.3 kilowatt, physical and chemical laboratory 10 kilowatt, CSD Hingna workshop and 30 kilowatt, workshop and store 215 kilowatt, energy to save 5% to 7% energy through conservation through solar energy. Energy saving through lighting by using energy efficient electric appliance. Most of the electrical appliance use CFT and LED lighting. To conserve the 5% to 10% to reduce the cost of electricity by replace of natural and other lighting system. Last, my slide is energy auditing and cost analysis must each department and each area of each company. So, departmental basis and company basis energy auditing is must yearly basis through the cost of consumption of electricity is more or less. What does the reduce the cost of energy in daily use is required. A pinpoint of opportunity to energy saving appliance is used in offices and home appliance. Save energy, save cost and better environment protection in future for next generation. Okay, thank you.
Thank you, sir. Any question? Okay, thank you. Thank you, Dr. Parvez. Yeah, thank you. Now I invite Mamata for her presentation.
Good morning, everyone. I'm Mamta, and I'm here for the presentation of the statistical evolution and hydrochemistry of groundwater from western part of Chandrapur district, Maharashtra, with special emphasis on human health risk assessment. These are the contents. Introduction. As we know, the water is most precious resource and very basic need for all living things, and the main study of my topic is the geochemical processes occurring within the aquifer are solely responsible for the geogenic changes in groundwater chemistry. Similarly, the anthropogenic activities responsible for the groundwater consumption from the dug well of ferritic aquifer tend to be more polluted than the deeper penetrated boreholes. Next. This is my study area, and which is covering an area about 334 square kilometer, and it is situated in the southwestern part of Chandrapur district. This is this stratigraphic succession. Hydrogeologically, my study area basically covered with the Neoproterozoic Penganga group of limestone, and it is covering about the 82%. The dug wells penetrating in Penganga limestone have an average depth between 7 to 8 meters below groundwater and have a diameter ranging from 2.5 to 5.5 meters. These wells have a groundwater discharge from 50 to 300 meters per day. According to the GSDA, the Deccan basaltic lava flows exhibiting the vesicular nature and disposed within the deep weathering as well as developed joints. The average depth of dug well in basaltic lava flows ranges from the 9 to 21 MBGL, and yield shows the greater variation from 75 to 100 meter cube per day. Next. These are the methods we have applied and about total 30 groundwater samples we have collected from the study area. The standard methods are prescribed by the AFA and followed by the laboratory analysis of these samples. The guideline given by the BIS and WHO were used for the standard analytical procedures. The principal component analysis with variation, where max rotation option was used for factor analysis. The factor loading helped to determine the relative contribution of geogenic correlation with the water. The concentration of NO3 and Fe have been taken for the computation of health hazard quotient for the children and adults. These are the analytical units. This is the health quotient, and we are calculated the health quotient on the basis of daily dose with the reference dose. Next, these are the parameters we have calculated from our study area. According to the cation and anion concentration in our study area, the cation hydrochemistry shows that the Ca is the more dominant constituent in whole watershed, where in anion hydrochemistry, the groundwater samples of HCO3 and SO4 are the prevailing dominant anions, while NO3 are the other major contributing anions with the dominance of dominant sequence of HCO3 is more than the Cl. Next, this is the statistical evolution where we show the positive correlation with pH with the alkalinity. With Na, that pH is more positively correlation showing with the NaF, which and as well as significant negative correlation between the prevalence alkaline environment for the dissolution of fluoride. The close positive interrelationship between the K, SO4, NO2 with the correlation coefficient values having 0.61 to 0.61, 0.63, 0.68 suggests that the derivation from non-geogenic sources like compost, fertilizer, soil are responsible for the NO source. Next, the factor analysis. Factor analysis basically depends on the Kaiser correlation criteria, which gives us the various factors to know what are the geogenic or anthropogenic sources of are responsible for the polluting the watershed. That the first factor has a strong positive correlation with the TDS, TH, Ca, Na and HCO, Cl, since it includes the TDS and the phi ions present in the basement of rock, it may be regarded as the geogenic factor. The second factor is significantly loaded on K, SO2, NO because these are present in the fertilizer and soil conditioners used by the people for the enhancement of crop production. This factor may be regarded as an anthropogenic source. The third factor is strongly loaded on a pH, THF, it obviously alkalinity factor through TDS previously belonged to the factor. It shows alkalinity for factor 2, which may be due to the contribution of SO2, NO2 and TDS. Health risk assessment. In present investigation, the concentration of NO found to be vary from 49.5 50 to 182.50 mg per liter. But according to the WHO guideline, it must be below 45. It is now medical fact beyond the higher concentration of NO3 causes methyloglobinemia, properly known as blue baby syndrome. This happens when there is not enough oxygen in the blood that gives a bluish appearance on the baby's skin. The table 5 shows that the health hazard quotient is ingestion oral of NO for the children and adults, men and women in the study area. Similarly, the present investigation, the concentration of F and found to be vary from 0.5 to 1.9, and according to the WHO guidelines, it should be below 1.5. last. Should be NO3, yes. The present study suggests that the NO may cause adverse health effect in order to the children, more in children than the adults, which are potential non-carcinogenic concern. Also, the study suggests that F may cause adverse health effect in order to the children, more in children than the adults, which are potential non-carcinogenic concern. This is the data we have calculated. As we see in this graphical representation, the rock-water interaction basically showing towards the silicate weathering. Okay. And here also we can see the log-log diagram which showing the more concentration of silicate weathering in the study area, ion exchange aspects, interrelationship diagram CaMg and SO2CO3 suggests the control of anions over the cations, also coexistence of ion exchange process with the other processes, the confirmed existence of ion exchange process, chloroalkaline indices, and Ca1 and Ca2 proposed by the Scholar were computed and they presented in table 2. The combination of itself depicts the reverse ion exchange processes in groundwater regime of study area governed by the equation. Conclusion: water samples of pH values ranging from the 7.6 to 8.7, indicating dominantly alkaline in nature. Almost 49% of groundwater samples show the TH value existing TA, which clearly indicates that the groundwater from the study area is distinguished by the non-carbonated hardness, which cannot be removed easily from the water. The Pearson correlation coefficient involving the parameters of groundwater represents positive correlation towards the TDS with the Ca, Na and K, K, SO4 and Cl. The significant negative correlation between Ca2 F suggests the prevalence of alkaline environment and distribution of fluoride in groundwater and elimination of Ca2 through the precipitation calcite. The factor analysis gives the strong positive loading on the TDS, TH and other parameters since it includes the TDS and 5 ion present in the basement of rocks. It may be regarded as a geogenic factor. The other factor which loaded K, SO2 and NO reveals the anthropogenic intervention in this study area. The present study suggests that NO and F may be cause adverse health effect in order to more in children than the adults. The children are more susceptible to the non-carcinogenic risk compared to the adults because of their smaller body weights than adult. This silicate weathering, carbonate dissolution, reverse ion exchange and anthropogenic intervention are the cause of change in chemical behavior of groundwater in the study area. These are the references. Thank you.
So any question from the audience?
Sir, nitrate.
It is NO3. It should be NO3. Not
It should be NO3, sir. Nitrate contamination. No, sir, it's
It is-
nitrate. It should be NO3, sir.
Thank you, Mamata.
Thank you, sir. Thank you, sir.
The topic for the seminar is for climate change. And initially when we started, Mamata is working with me. Initially we found that from Yavatmal district, some of the patients, they are coming to Nagpur, particularly for kidney problem. Dr. Ukalkar from his nephrologist, the team of nephrologists, myself and Neeri, we tried to get the result why the kidney patients are coming to the Nagpur. And day by day we found that the number is increasing. So after the initial investigation, we could found that after getting some 600 samples of a male, we found that, and after going through the DNA modeling, we found that the Pradhan community or male from the Pradhan community, they are facing the problem of thickening of the kidney wall. Then we also carried out the DNA modeling from the females also, but the problem was taking the pills, means to go to the farm and after coming back from the field, due to the body aching, females used to take the pills, just like Combiflame or Ceridon, whatever it would be. Another problem which was coming, that is the non-carcinogenic, which Mamata has pointed out. From last season, we came to know that the number of patients, they are coming to the doctors which are dealing with the skin problem. And as there is much intake of water, either orally or from the skin, that is nothing but the dermal. And we found that the problem is increasing day by day. And hence, or after that, we tried to get we tried to investigate the problem, and we could found that the particularly NO3 and F, means fluoride ions. These two ions were the culprit, major culprit. Though the people from the residential area, they are coming to the Nagpur, but again the problem particularly from residential area, that is nothing but the fluoride ion. And in the city area, again the fluoride is the geogenic problem, and that was the initiation of the problem. Thank you, Mamata. To sum up this session, I authoritatively request he can authoritatively sum up the session. So I hand over to Dr. Krishna Kumar.
Thank you. Actually, in the technical session 7, actually there were 5 purposes, only just 2 purposes are actually listed here that were presented. Actually, this paper, the last paper, has been taken from another session. So, in this session, just I would briefly just give a respond that. So the rare earth elements so that are very important, especially in climate change perspectives, and so as per the Nidhi Ayog's direction, as well as the Geological Survey of India, so the study of so many coal seams in India. So the critical non-fuel mineral resources of India, so that is very important for a study concerned, especially climate change point of view. So the present situation of utilization of valuable elements from coal, that is also very important. With regard to the importance in coal gasification and all and climate change perspectives, our last budget has just earmarked for 30,000 crores for that such kind of studies, especially in developing technologies in both in R&D as well as in the company perspectives. So coming to the next presentation, so that is highlighting the conception of the resources in drilling operations. That is also a topic of interest. So he concised that the regular energy auditing for arriving meaningful interpretations regarding energy conservation measures. So the third paper, so my colleague has pointed out, so the health risk that is involved, especially in the groundwater, is very important. So any studies that is relating to groundwater, that is very socially sensitive also. So since that point, that such kind of studies that is very essential, that is lacking in different regions of India. So like NO3 as well as F, so that is having serious concerns. So regarding the quality perspectives, both the geogenic as well as the this anthropogenic interventions are there. So that kind of studies also be promoted. So that is also very important. So this is sum up of this technical session. I think the time allocated that for the sessions, that is up to 11:25. I think so we are running before time. Okay, thank you.
On behalf of organizing committee of the seminar, I like to thank our chairpersons, Dr. Krishna Kumar and Dr. Y. Murkute, and to acknowledge for their time they have given in chairing the session. I like to request Dr. A.K. Chatterjee sir to felicitate Dr. Krishna Kumar sir with a memento. to felicitate Dr. Y. A. Murkote, sir.